Thanks for joining us for today's webinar. We're going to be starting in just a moment. All right, welcome to another Dotmatics webinar. I'm Ryan Barbera. I'm excited to get us started today to discuss how to accelerate chemicals and materials R&D innovation with next-gen technology, presented by Jess Sager, who is the practice lead of worldwide pre-sales at Dotmatics. Today, Jess will share the challenges of innovation, how to achieve nirvana when it comes to a future-ready lab, and he'll discuss how Dotmatics can enable that journey to nirvana. Before we start, I'd like to highlight a few important details. Please note that this webinar is being recorded and we will share it with you after the event. Additionally, for your convenience, we will host it on dotmatics.com on demand. Throughout the presentation, should you have any questions, there is a Q&A module located at the bottom of your screen. So feel free to submit your questions there and Jess will address them at the conclusion of today's session if time permits. But now it is my pleasure to hand it over to Jess.
Thank you, Ryan. So, as Ryan said, I'll be talking three main points today. So we'll talk a little bit about the challenges in chemicals and materials, and one of the big challenges is how to do things faster. So we'll spend a lot of time talking about accelerating the process and doing things faster. We'll also talk about attaining nirvana, which I kind of almost put in here as a joke, but it kind of stuck. But what is the desired result of the future-ready lab? And also, then finally, how Dotmatics enables that journey. Before I leave this, as part of the introduction, I'd also like to make a definition for the purposes of this presentation. The term chemicals and materials, or C&M, appears a few times throughout this presentation. I just wanted to let you know I'm using this term a bit over broadly to refer to all industries that do chemistry and formulations outside of life science. It's not a fully accurate term as it seems to kind of ignore sectors like food and consumer products, but rest assured, I mean all of you, so please feel included. Okay, let's launch here. So the first section we'll talk about is challenges. And I call this faster, please, because one of the main challenges we see is needing to do research faster, to get to that material faster, to get it on the market faster. Many companies in this space have customers coming to them, internal or external customers, with requests for materials with specific properties. These requests often need to be actioned within weeks, sometimes within days. You may have a regulation come out that restricts usage or access to a key ingredient, and you have to reformulate without that ingredient. Everybody knows about supply chain after the last couple of years. COVID obviously had a large effect, but this can be affected by many things across the world. Conflicts, weather events such as hurricanes or typhoons, trade deals or lack thereof, taxes, all of those things can affect your supply chain. Many companies in the C&M space or in this space have a much longer history than life science companies, for instance. You have larger organizations, ingrained traditional processes. Those things mean that the data is in many different states, and the projects to digitize these workflows are at many different stages, including in reports, in data silos, or even on paper. Also, the processes here vary widely. Someone who is making shampoo is going to have a very different set of processing conditions and tests than someone who's making tires. So also equipment varies widely. So you have a broad range of equipment that you use to actually execute these processes and tests. Another example of challenges faced. In the last 5 to 10 or even more years than that, everyone has started to talk heavily about sustainability. Everyone wants less waste, wants to pollute less, and in general be nicer to our planet, since despite decades of musings by science fiction authors, it's still the only planet that we have. This is just another of the challenges that this industry faces. I've got two examples here. The one from Adidas, where they're making shoes from biofibers that are biodegradable. I personally think that's pretty cool to be able to have my shoes biodegrade when I'm done with them. And then Lego, hoping to make most of their products from sugarcane by 2030, so that those are also sustainable and biodegradable. So that when you're wandering around in the middle of the night and you step on your child's Lego brick, you can at least know that it's sustainable. There's always a stepping on a Lego brick joke there. But so C&M, or this space that we're talking about here, is not life science, and we want to acknowledge that. There's different needs. Dotmatics does work in the life science areas, but we want to acknowledge that things here are a little bit different. There are similarities. Everyone does make, test, decide. We call this the innovation cycle, where you make something, you test that thing, and then you decide if that's the thing that you wanted. And then based on that, you make a decision and you make a new thing. Everyone needs to see their inputs versus their outputs and learn from the past. What did I do yesterday? What can that tell me about what I need to make today? But in this space, in the C&M space, what you make is different. And then how you test it is different. Those are obvious things, that those things are different. Some less obvious things are there's more agility required. The time cycles tend to be shorter to respond to those internal and external market needs. Also, interactions with a wide variety of equipment across the workflow. The processes are more varied, so the equipment is going to be more varied. Well, this space, this C&M space that I'm calling it, varies widely. There are common challenges that can leverage common solutions. For example, everybody deals with data in projects. It's a classic human way to divide things up. You put it into a project, it makes it easier to find data. It's a container to keep similar data in the same space. Composition, how much of what ingredient is in there? What are all the ingredient lists, the amounts, and so forth? Processing, what did I do to make my product or my thing? Heat, pressure, extrusion, mixing. What are the conditions that went into that? And then finally, analysis, characterization. What questions do I want to ask of my data? What do I need out of that? Is it a report? Is it just is it a graph? Is it what I need to do next? What questions do I want to ask? The questions are almost always things like, what do I have to change in my inputs to get closer to my desired outputs? Or, what do I have to change in my formulation to make the material that I want with the properties that I want? Different companies, different organizations have approached this in different ways. Well-known legacy software types that have been used to address these challenges include ELN, LIMS, and proprietary instrument software. And I'm sure if we polled people, there'd be a few other ones that pop up, but those are the common ones that we see. A colleague of mine at Dotmatics did a webinar for Chemical and Engineering News late last year. And as part of that talk, he took a poll about where the attendees were in their informatics journey. Companies are at a variety of different stages with a variety of different goals. So I found interesting in the top graph that a lot of people, basically the top graph tells us that people are at all different stages, and most people are very much still on a journey. In this one, 36% were interested with no plans yet. There was no disinterest, but I mean, they attended a webinar on digitalization, so they sort of self-selected for interest. And then everything goes across planning, isolated systems, digital but poorly integrated pieces, and an integrated digital system. Most people, there's only 7% of the people in that webinar of people interested in digitalization that have actually made it to what they consider an integrated digital system. So everybody's on a journey. Objectives, I found it interesting that boosting efficiency, again, the whole idea of faster, please. How can we get that product out the door faster? Is 44%. And going down with data quality and data transparency, but also there were a lot of people, fully a third of the response a third of the respondents were interested in building an AI ML environment. And I'll talk about a bit about that later in the presentation. So the impact of informatics, just to read the quote, 80% of decision support is based on connecting structural properties to test data. In other words, connect my inputs to my outputs. That's the challenge. And any informatics system that you use is going to need to accomplish this. What do I change about the things I'm putting into my material to get the properties I want out at the end? That's the question everybody needs to answer. So some of the challenges and kind of how those challenges have evolved over the years. And these are changing on a regular basis. We've been using instruments for analysis and measurement for many years at this point. Early on, the challenges were simple, or simpler. You generated data, then you processed the data, reformatted, did any necessary calculations, and then you analyzed it, referenced previous or standard results, made comparisons, drew conclusions, which led to a decision and designing the final product or the next thing to try. Oftentimes, we talk about data retention down here. Oftentimes, the raw data was not kept, at least in an organized fashion. We would just record the final results and share those and keep those. And part of that was because in years past, the technology wasn't as up to dealing with large amounts of data, and we were also collecting, and we also didn't need it as much. We just needed those final results, or that's what we thought we needed. There was not a lot of automation, except some limited cases of data processing. Nowadays, that's become more complex. First thing you notice is there's a lot more arrows. So we come back and we reanalyze and we recycle at parts of the data flow process. We've also added a couple of steps in here. So first of all, we have more instruments generating more data. We talk about big data. There's a sea of instrument data out there now. And so we have had to add a data management step after generation. It's partly because we're keeping more of the raw data. The technology is now up to it. We talk about data lakes and big data. We have all this data coming off of instruments that we need to manage and we need to do something with. We need to store in a retrievable format. So we've also found that sometimes we need to go back and reanalyze. It's some of these arrows that are coming back here. Go back and reanalyze. Maybe you have a new application for the product that you tested 3 weeks ago or 3 months ago, and you want to analyze it for that. So now you have the raw data, you can go back and do that. Once you've analyzed, we're often now doing data modeling, and that's new. And data modeling can be anything from looking at trends and graphs through basic statistical analysis to full-on AI, which again, I'm going to talk about in a bit. We're also sharing data across groups, more often across often across geographies. We're a much more global research organization now. Different parts of the process could easily be done in different countries. We're trying to automate as much as we can to get through the process faster. All of these things, the fact that there's more data, the fact that it's spread out across potentially countries, and more people are getting their hands on it and doing things with it, adds a layer of challenges that come up with this. And this is a bit wordy. I'm not going to read through it, but you can see that every stage of this, challenges pop up, and some of the same challenges pop up at different points in the research process. So things like data curation, lack of fair data, loss of content, loss of standardization. There's a lot of things that can happen that can be challenges here that we need to use informatics to solve. Okay, so where are we going? What is Nirvana? What does this future-ready C&M lab look like? So objectives here, I've got my pyramid. I'm going to start at the top. So the end goal at the top of the pyramid is accelerated innovation. Get that product out the door quickly so it can bring in money. You can move on to the next thing. To do that, we need to get a handle on our data. We need to make it findable, accessible, interoperable, and reusable so we can learn from what we're doing today and what we did yesterday and the day before that and the week before that and so forth. To do that, to get to the accelerated innovation, we need to have operational excellence. That means we need to be able to collaborate across groups, across geographies, and we need to simplify, standardize, and automate as much as we can. To do that, the operational excellence, we need to make it easy for the individual contributors to use. It is critical that the system be easy to use in general and by a workforce that is sometimes remote. We all know what happens to systems that individuals hate to use. Those systems get worked around, and now you've got data in multiple places again. So all of these things have to work together to be able to accelerate your innovation and speed the process of research. So we're going to look at a couple of scenarios of digitalization. So the first is an application-centric strategy. In this strategy, we have a bunch of point applications. Some of those point applications are used in different pieces of the process. Sometimes there are different applications that are used at different phases of the research process. So advantages of this is you can pick best of breed. Each department at each phase of the research process selects specialized applications that work the best for them. Point solutions such as this, point solutions have been around a long time, so they are oftentimes very mature and very accommodating and very feature rich. It also accommodates regional and cultural preferences across geographies, across cultures. Different people have different preferences. Disadvantages of this application-centric, you have collaboration challenges. Information, best practices are all isolated because people are using different applications. The challenges in you have challenges in leveraging the knowledge and data. Again, it's fragmented, it's in different applications that are hosted in different places. It's a hard to maintain IT infrastructure. Upgrades, rollouts, IT people hate this because they have 27 different applications they need to upgrade, they need to manage licenses for. There's a lot of things that they have to keep track of in order to manage all of these different applications. One way to help with that is to go to an application-centric platform. So here you've got a bunch of different applications that still exist up above, but they're connecting into a common data platform. So advantages of this are that you have much of the data in a common interoperable platform. Although because you have data coming from different applications, some of that data still is in different data models. But you have the advantage of some point solutions that meet specialized needs of certain groups and workflows. But disadvantage, you're still left with disconnected pieces. The data doesn't always talk even in the platform, and you can have data in applications that is easy to miss, and it becomes orphan data and you lose track of it. There's also still a pretty good sized chunk of IT overhead to manage both the platform and multiple point solutions, many of which are often on local workstations. Taking this to sort of the logical next level, you have a full platform. So advantages of a full platform, and a full platform, I mean, you're using the same applications across the entire research process. So advantages, everything is interoperable. It talks across the functions by design. It's designed to do that. The data is consistent. You have one database, one data model to rely on. You have one system to maintain and train users on, so everybody gets the same training. Disadvantages of this kind of system is it's one system for all, and it might not fit each and every group perfectly. You're going to have people that love the system, and you're going to have the people that love it less. You're chasing best of suite rather than best of breed. So you have to look across the entire organization, the entire process, to pick what's going to be best for your organization. Adjacent to this are situations where you still need to have best of breed applications do specific actions for you because they're best suited to do that. You can have a situation where you outsource certain calculations or functions to a non-platform application, but still store and access any results or data via the platform. So you still have the advantages of the platform, but you can take advantage of some of those mature point solutions. Okay, I said a couple times that I would talk about AI. Here's where I start doing that. As we all know, artificial intelligence and machine learning are a very hot topic right now. This is a very, very quickly evolving space. I can almost guarantee you that a year from now, or even 6 months from now, this conversation will be in a different place because it's moving that fast. Everyone is somewhere on the AI ML journey. We saw in that graph earlier that a large, fully a third of the people in that previous presentation said, yeah, we want to do AI ML. Most organizations are in the process of wrangling their data. Because once you look at this, you realize very quickly that you need to have your data in a consistent, readable format in order to apply AI or ML. And not just some of the data. You need both the inputs and the outputs. Most companies in this space, and most companies in all scientific domains, are still on the digitization journey, and the data needs to be accumulated and organized before AI really even has a chance. Companies are starting to get analytical insights from simple predictive models, but truly automating the process through the decision making is still an aspiration for most. Moving to the right on this graph more or less defines the goal of driving toward data-driven R&D. This is the goal. This is the future-ready C&M lab that accelerates those insights. So this is moving to the right here is what everyone's trying to do. So as I was preparing this on a lark, my colleague said, why don't we ask AI what AI will do for material innovation? So we asked ChatGPT, how will AI revolutionize material innovation? The answer contained a lot of aspects we've already talked about and does a reasonable job of laying out some end goals for data-driven R&D. So, material discovery and design. It talked about accelerating the process of discovering and designing new materials. And AI can analyze those vast amounts of data. So that goes to accelerating innovation. Predictive modeling, predictive models and simulations for material behavior. Material characterizations, being able to recognize patterns and features in things like images, like electron microscopy. AI is good at that. Optimization, iterative design, optimizing material properties based on a specific criteria, and then recycling and sustainability, the waste reduction that we talked about before. Everyone is looking to do this. We want to take care of the planet. And at the end, it says, overall, AI has the potential to significantly accelerate material innovation, improve material performance, and drive advancements. That is what we've been talking about this whole thing. And hey, ChatGPT agrees with me. But the other thing to be aware of here is, have any of you ever played with ChatGPT and unintentionally fed it info without the proper context or questions that have some ambiguity? Context is important. Think about, back in the 80s, they used to say garbage in, garbage out. This very much applies to AI. And yes, I'm that old to remember that. So at the end of the day, so I looked around the internet a little bit, and there's a lot of stories out there about AI failures, particularly around ChatGPT, because people like to poke fun. And some of it is funny, and some of it's fairly serious. But I just pulled one example where a Texas professor failed a bunch of his class after ChatGPT falsely claimed that it wrote their papers. So he gave it bad data, and ChatGPT, as it turns out, really wasn't set up to answer the questions the way he asked them. And so he got the wrong answer. So What you feed in is important. And at the end of the day, to do AI, the organization with the best organized, most accessible data wins. So you need to get your data in that format to be able to, for AI to really even have a chance. And once you get that, it has the potential to significantly accelerate things for you. Okay, so how can Dotmatics get us there? So we're building the most powerful scientific R&D platform in the world, connecting best-of-breed applications to enable collaboration, automation, and insights. What we have today are best-of-breed scientific applications that add a lot of value to the day-to-day of scientists. We have an open, flexible platform to manage your data, and we offer customers the most value they can get from their data. That's where we're at with Dotmatics. And what does that look like? First, we have solutions. So within Dotmatics open flexible data platform, we've built standard solutions. The CNM solution is an off-the-shelf offering that came out of our experiences with what our customers want. It encompasses an end-to-end workflow that covers this whole make, test, decide innovation cycle that I've mentioned. It can be used as is, or as a starting point for even more complex configured workflows. The Dotmatics platform covers both the ELN and LIM spaces, enabling capture of data about ideas alongside more structured sample-based data. Most of you are familiar with what LIMs are. Laboratory information systems. They've been around for decades. LIMs are mostly about samples. They do bring operational excellence, traceability, and compliance to laboratories, but it's mostly about analyzing the samples. I have a set of samples, I am testing those samples, and it tracks all of that in great detail. However, LIMS alone does not give you the context for your data. This is critical when using the data to make decisions. The Dotmatics platform captures all the concepts in the typical CNM workflow, including the formula or the recipe, what's in the thing that I'm making, the process, what did I do to the thing, the conditions that I exposed it to, the steps that I did to make it, and then the performance. Does this product or thing that I have made have the properties that I want? So the Dotmatics platform captures and connects all of this information, enabling you to ask the question, can my data tell me what to make next? And that's what we're trying to get to. We're trying to get to that point more quickly. What do I make next? Do I have the thing I need, or do I need to move to something else? I've talked about the innovation cycle. So this is a visual representation of it. So just walking through, I'll start with make, and we've got the innovation cycle and how the Dotmatics platform maps to that. And so I can capture my ingredients and my processing steps, my process development in the make section. And then as we get into test, we can generate samples, print the barcodes, associate analytical data, do some analytical application testing on those samples. And then as we move into decide, we can search formulations and compare things within the search results, generate reports, and then go to data visualization for comparison across large amounts of data. We can also use requesting tools to specify the market need, internal or external market need, to stand up a project which will gather all the data associated with that need or project, making it easy to find. So we've contained it. Those requesting tools are also applicable for the testing. You can go out and request tests for things, as I'll show in a moment. So now I'm going to talk through in a little bit more detail what this looks like in the day of a life of a scientist in the Dotmatics world. So we start with make, and the first thing we need to do is we're gathering a list of ingredients. Here I show it coming from an ingredients database. In this case, it's coming from an internal Dotmatics ingredient database, but it can be configured to point out to an ingredients database you already have, if you have all that stuff in your ERP system, for instance. So we'll gather a list of ingredients. We're going to enter and view the planned and actual amounts. For, in this case, I've got two formulations here. So I've got my planned and actual amounts. Are my actual amounts varying too much from my planned amounts? It'll flag me. And I also have references to inventory for each individual ingredient to tell me, do I have enough in inventory to actually execute this formulation? So, and then processing steps, capturing the equipment, as we see here in the center, the equipment that I'm going to use, the calibration information about that equipment, and then the processing steps that I actually executed to make the product that I'm making. So then once we've made our material, we can move on to testing. Testing results can be attached to the original experiment by the person doing the formulation, but can also be requested for other scientists or labs to perform. And here you see me with two samples that I've requested a tensile strength test on, and it's showing me those. I can set priorities and send it to specific individuals or groups, and then track those requests. These show complete, and there's links out to the analysis experiments if I want to follow that. But then once the analyst or the person I've sent that request to has executed that, those results come back to me. And you can see I've moved from the test selection to the test results tab. As the formulator, all this information flows back to me. And here I can see those tensile strengths for the two samples. I can see the numeric values, whether they fall in or out of spec, and the actual tensile strength graph from the instrument, which I can click on and blow up for easier viewing. It's all right here at my fingertips. And then finally, under Decide, we have the input and output data in the system. It's easy to query the database for what you need. Query by any field, including project, date, ingredient, amount, process step, formulator, test results, and on and on. So we can comparing the inputs to the outputs in the query results, or in one of our powerful visualization tools, allow you to compare results across experiments, look for trends, and decide what to make next. Because that's really the whole goal of this. What do I make next? And getting to the answer of that question as quickly as possible. So what makes, okay, so I spoke 10 or so slides ago about the role of AI and ML. The workflow I just described gets data into an interoperable, reusable format that helps make your data AI ready. That's digitizing your workflow. You're capturing it into a system that then is searchable and retrievable. The right side references the steep part of the curve from the AI journey, that graph that I showed you earlier. So we want to capture our data digitally, but then we need to wrangle that data and organize it into a way that AI and ML can consume. So you cannot get to AI unless you've gathered and organized your data. So we need both of these steps in place, and Dotmatics has tools for both of these things. So what makes Dotmatics unique? We've talked a lot about data-driven R&D. This is all about unifying the data. And the way we do that is we have a platform with natively interoperable components. So all those components talk to each other, and they're designed to talk to each other and exchange data. Also, our search technology was designed from the beginning to federate searches across databases. So we can integrate with data from other places and have integrations with best of breed point solutions. We have a configuration-driven interface. We have out-of-the-box templates and have the flexibility to configure other templates for specific workflows, allowing the system to closely mirror and enable your workflows and capture the data from those workflows. Data out capabilities. I'm fond of saying that if a system, that it doesn't make sense to put data into a system if you can't get it back out to use it and learn from it. So we can query against any field in the domain and execute a round trip with our data discovery. We query, visualize, decide, and report. This is a small selection of some of the companies in this space using the Dotmatics platform. I went down the list and picked out a few that were recognizable. And they're using the Dotmatics platform to digitize and accelerate their research. One example that I picked out further is Croda. Here, Damian Kelly, the VP of Information and Technology at Croda, talks about how Dotmatics is an important part of their digital program and enables rapid and easy access to research data. He goes on to talk about how this access to research data and accelerating the development of their technology platforms drives them to their goal of delivering the best sustainable solutions to their customers. And meeting those needs. So with that, just by way of summary, I've talked about the challenges that we face in this industry, in this space we're talking about, what those challenges look like, what the end point, what the nirvana, what the end goal of this journey that we're all on, what we think it is, and what that looks like. And then how Dotmatics can enable that journey, how we can travel along with you on that road and help you get to that end goal. So with that, I'll say thank you for your kind attention. Thank you for attending.
Yeah, thanks, Jess. Lots of good information shared. And again, if you have any questions that we did not answer during today's presentation, or if you would like a custom demo of the solution, you can reach out to us at dotmatics.com. I want to thank everyone again for joining us. As a reminder, the recording will be sent to all participants. So keep an eye out in your inbox in the coming days and you'll see it come through. Thanks again. Thanks, Jess. And everyone have a good day.
Thank you all.